Welcome back to another design and engineering technology video on Onshape. Today we will be teaching you how to create a layout or a drawing of the wooden toy that we created in class as a practice. And we're going to download a title block that I specially made for this course so that we can add those views and add in all the dimensions. So the first step is going to be if we go to the Google Doc that talks about how to create the Onshape layout drawings. I do have steps there on what we're going to be doing right now in this video. And the first step here is to download the title block. So you can click on this link. It'll download a title block. It will go to your downloads folder. I'm not sure what happened here. There we go. Download. It downloads down here at the bottom, as you can see, to your downloads folder. We go back to Onshape and we are ready to go. So with your toy Part Studio open and ready to go is to actually upload that title block that we just downloaded. So we have to hit the plus sign down at the bottom and go to import. And we're going to import that file. And that went to our downloads folder, so we can check in the downloads folder, and there it is. I see it, 001A title block template. Select that and click open. You will see it'll ask you here, or it'll show whether whether it's in progress or completed. It is completed, so we can sort of delete all here, close that, and you will notice that there is now a title block template tab in your Onshape file. And all we really need to do here is just right click on that Part Studio tab and select Create Drawing. It's going to ask you for a template. And if you go to My Onshape, you should be able to see that title block template that you just uploaded. Obviously, I've done it many times. So let's hit OK. It will give you sort of a blank slate with that title block, and it will prepare putting in the Part Studio views. Now, obviously, the first view I have there, it is a side view, but orthographically, we'll sort of call that a front view. The top view automatically sort of creates itself. I can select this front view and then project other views off of that. Right side view, left side view, bottom view. I could even project over, if I go off diagonally, I can project an isometric view. So a lot of things that you can kind of play around with there. Hitting escape on the keyboard allows you to get back to your cursor mode. And if we consider this object, ultimately the side view and the top view is really sort of unnecessary. We do have this hole here, but we can sort of dimension that in a different way later. I'm going to actually delete these two views so that way I can make this view larger to fit my title block. As you can see, this view is very small and doesn't really leave a lot of room for adding dimensions. So the first thing we'll do is actually increase the scale. So I can increase that by highlighting the view, so the whole view is highlighted, right-clicking, and going to the View Properties. In View Properties, you'll notice that there is an option for scale. They give you several options here. I can go 1:1, but I'll notice that that is really large. And you'll also notice that my isometric increased along with it. So, and you'll notice too that it shrunk back down again. So when we do the View Properties and we do change anything about the scale, let's do 1:2. You have to hit the green checkbox to sort of accept that change. But you'll notice that both views increased accordingly to that one change. I can change individual view scales by selecting that view, right-clicking, going to View Properties, and making sure it doesn't say Parent here. Parent means it's tying it to the parent view, which in this case is that side view of our toy. So if I change that and make this, I'm going to make this small third, maybe a little bit smaller. We'll see what happens here, fourth. And notice that it is no longer tied. They can have separate scales, and that's okay. Again, select the green check to accept that change. And again, I can just sort of move this off to the side. So I'm about ready to add dimensions. I'm not totally happy with the scale. It's still somewhat small compared to this example here, where you can see it's very, very large. And it allows me to put my dimensions in and see them very clearly. So let's go back and change the scale. So I'm going to right click. I'm going to go to View Properties, and I'm going to change this scale. The scale that I want is actually 3 to 4, or 3/4 of an inch is equal to 1 inch. So I can actually select or actually make my own scale by simply typing 3:4, which means 3 inches on the drawing is equal to 4 inches on the object, or 3/4 of an inch on the drawing is equal to 1 inch on the object. Hit enter. So hit the green checkbox to accept the change, and we're ready to dimension this object. The little scale that it gives you down here, we can actually move that as a separate box. We can always move that into our title block as such, but it is tied to the view. So if I move the view up or down, you will see the text actually moves with it. So just be careful of that. It may be easier to simply delete that and double click the scale text box here and literally type it in yourself, and type in 3/4 inches space is equal to 1 inch. Right, so that is what the scale is. And hit the green checkbox to accept. And there's our scale. So let's dimension this thing. I'm going to move this isometric view out of the way for now. I can always move it in a different place. So the first thing I need to do is I need to turn on my hidden lines. If there are any hidden lines, this object will have a hidden line because we have the hole drilled into the center here. So we can just right click on the view and say show hidden lines, and it'll automatically add hidden lines wherever they are. I do need to add center lines. This object has several arcs and drilled holes, and they need to have center lines drawn there. We are going to be using mostly the 2-point center line tool. The center mark tool simply just puts a little, plus sign at the center of an arc or circle, and that's not really what we want. So I'm going to Control Z that. I'm going to undo that. Sorry, Control Z. I'm going to use the 2-point center line tool, which allows me to get in here and find the quadrant points. And you can see how the cursor highlight changes when I find the quadrant point. And I'm going to scroll down, and it inferences off the center or inferences all the way over to the other quadrant point. And it gives me a really nice center line that extends beyond the edges of the arc or drilled hole that I am dimensioning. So the horizontal one, again, I can see how my cursor changes when it snaps to the quadrant point. And I only need to go to the other side of the drilled hole here, and it extends a little bit beyond the drilled hole, but it extends all the way beyond the edge of that arc. So that's a nice center line right there, and I just need to do that throughout. So likewise down here, I can create a center line from here. I'm going to go all the way across to communicate that the drilled holes and these arcs have the same vertical center. And then I will draw a vertical center line that only goes to there. Likewise here, we can draw the center line for this really large arc. And this is slightly difficult, but again, if you mouse along the edge of the arc, it'll snap to and inference the center. So that allows you to go all the way to here, and I can start all the way up here and go all the way essentially to the midpoint of this bottom side right here. And this will be good because we have symmetry on this side and this side, so might as well have that center line come all the way down so I can dimension off that. Then I have my window, drilled hole here again, find the quadrant points, and we have some excellent, we have proper center lines. Once we have the proper center lines done, we're ready to dimension. What's great with having the center lines and the dimension tool is I can certainly dimension if I just click on some aspect of the geometry, like this line, it highlights, and when I throw in a dimension, it dimensions it just fine. But you'll notice that the extension line actually extends down into the object and covers up that center line that we kind of worked hard to do. So I'm actually going to delete that dimension, and instead, when I choose a dimension, I'm going to dimension from the end of center line to the end of center line. And you'll notice when I place my dimension, it creates a little extension line gap from the end of the center line. And that's really what allows us to clearly and effectively communicate size and shape simultaneously. So again, I can kind of go ahead and just dimension this object, and I'm dimensioning from the end of the center line. And you'll notice that as I place dimensions, they can snap to other dimensions. So I want to make sure that those dimension lines really line up nice and neatly. And I can always hit escape and get back to my cursor. I can select a dimension and I can move that dimension around. Obviously, I can move it further away, or I can make sure that they are snapped. There's the handles to the actual arrows. So I can click these handles and push the arrows to the outside or push them to the inside. I can even select these little blue dots and move where that is attached to. So I can actually attach it to the end here, or I can attach it to the quadrant point of a circle and get that dimension to the end quadrant there. If you zoom in, you can still see that there's that extension line gap. But it is always better and more efficient to dimension always to the center of an arc, and then to simply add whatever the radius is of that arc. And again, notice I line these things up. I'll do that on this side right here as well. I'll have a dimension and I'll inference. So if I'm looking for the total length from the end of this arc to the end of that arc, it's much better and more efficient to actually have the radii and the center to center distance, and that way you just add those numbers up and you get the overall length. That is something, again, that we explained in class, so hopefully you understand why that is more efficient and why that's important. Okay, so what I've actually done here is I fast forwarded a little bit, and I added some dimensions here. Like I said, it's really important that we dimension from center to center, and I added the mirror aspect so that this dimension and this dimension are the same, but then the entire dimension here, and then we can add on the two radii. So if I really want to know the total distance from this edge to this edge, I only have 3 dimensions that I need to add up, and it's pretty quick. Zooming out, you'll see that I've added in some other dimensions. Notice that the dimensions are spaced away nicely. I've dimensioned to the ends of center lines. So it's very clean and very clear. The communication of size is very clear. Again, up here, I did that dimensioning from the center of this big circle to the center of this arc back here, and then I add on the radii. So if I want to know sort of the overall length here, again, I can add on this radius, that dimension, and the radius of this big arc right here. I've also located the center of the window of the helicopter, and I've given the size of those. Now, what I want to do right now very quickly is, if you'll notice, we are using decimal inches. The project is in inches, and it's fractional inches, since we're going to be going in the shop, and the majority of the machines in the shop and the rulers we have in the shop are all calibrated to fractional inches. Let's change these dimensions so that they are in fractions and not decimals. So if we go over to the wrench, this allows us to look at the units and the precision. Right now the units are inches, but if you look, you can also get fractional inches. And before I select that, I want you to understand that we can adjust the precision of any dimensions that we put out here. So if I really only want to show 2 decimal places, I can choose that, and then every dimension will just have 2 decimal places. I could obviously, make the sky's the limit, but that's really unnecessary. So let's take a look at fractional inches, and you'll notice the precision here is a 256th, which we really don't need that kind of accuracy, but let's say our accuracy needs to go down to at least a 64th of an inch. Although if you design properly, you should never have to have any kind of fraction that's less than an eighth. So what we need to add, we still need to add the drilled holes, dimension for the drilled holes, for the tail rotor and for the axle clearance holes, and these radii, these blending radii. So let's go ahead and do that. And there's two things that you're going to run into. I can actually dimension this using my dimension tool up here. And if I select that, it comes out nice. It's 9/32. That's the only fraction that we should have that'll be in the 30 seconds. Otherwise, all your other fractions should be no smaller than eighths, according to the project. This, I have two of those, so I could dimension them both, but then I have a problem of where this dimension goes over on this side of the toy, and it kind of gets a little bit messy. So I'm always trying to go for clarity of communication, in this case, communication of size. So I'm going to forget about this dimension. And what I'm going to do is, since both holes are exactly the same size, I can actually take this dimension, click on the little menu here, and in the suffix, so at the end, I can put a x2. If you go back here, you can see that just puts in ×2. So there's two holes that are 9/32 size. The only thing I like to do for clarity's sake is actually put a little bit of a space. So again, if we select that dimension in front of the X, I just hit the space bar once, and then I look again, and it just cleans it up a little bit, and it makes it a little bit easier to see. Now the other option to do these holes, so again, if we take a look at the example here, you can see the tail rotor, that hole does not go all the way through. It actually only goes to a depth of 1/2 of an inch, and then we have to deal with somehow dimensioning this. The rules state we shouldn't be dimensioning hidden lines, but at least I'm just making an arrow here and a note for how big that hole is going to be and how deep that hole is going to be. And in this case, I've made a note that it's centered on the thickness. So let's talk about how that's going to get done. As I said, there's two ways to dimension a drilled hole, and it really depends on how you created the hole in the 3D model. If you created the hole using the hole tool, then you can actually utilize this hole callout feature, which is really nice because then it does all the work for you. And you can see there there's our dimension. It's a 1/4 inch diameter hole, and it goes to a depth of 1/2 an inch. If we just use the regular dimension tool, we have to add that information in ourselves. So yes, it gives us that it's a 1/4 inch diameter, but instead I need to go in here and add in some information. So I need to add in a symbol, depth symbol, and I need to add in that it's a 1/2 inch. If you look, there it is. So two ways to do this, using the dimension tool or the hole callout tool. If you create the holes using the hole tool in the 3D model, then you can use the hole callout. Otherwise, you'll have to add it as a suffix. So it's entirely up to you how that works. And finally, we have to do, how do I add the note here? Well, adding a note is really easy. Adding a note, you can add in all kinds of symbols here. So we can add a symbol here, 1/4 inch, space, and then I can add in the depth symbol, 1/2 inch. I can lengthen this note so that there's space for all of it. And then I can say hole centered on things. the whole center bond thickness. If that looks really weird, we can always double click it and again adjust. If I adjust the length here like this, then that makes it a little bit better. But now I need to add a little arrow over to where it's actually showing this. So I can do that by using the weld symbol. The weld symbol is going to go something like, just looks a little bit like a line. I'm going to just sort of click roughly in the middle here, and that gives me a little arrow, and I can make that arrow kind of slanted like this, and then it automatically gives me another one. I don't need that other one, so let's just hit the green checkbox, and then let's take our note and move our note a little bit so that it's centered on that leader. And once you have that in place, you have all the dimensions except for these blending fillets. Now, I adjusted the design, so I think the original design showed these fillets as different sizes. And I think if we look at them again, I could go about dimensioning all of these, but it just adds a whole bunch of arrows and numbers, and again, reduces the clarity of the communication of size. So instead, what I would tell you to do is to, and you'll notice I made the fillets all the same size so that I could simplify this whole kind of helicopter design. Now, it really doesn't change the shape that much, just having them all the same size, so why not? And all I need to do here is change this and add in a space, X3, and I have 3 radii, so these radii that are not dimensioned are dimensioned right here, 3 radii that are 5/16 radius. And we're essentially done with this layout. I still have my isometric up here in the corner, and I'm going to swing that down here where there's an open space. And it's nice just to have a 3D isometric view of the object, just helps with visualization, so why not? And what I can do with this view is I can actually solidify it or make it a solid view. So I can right click and I can go show as shaded view. And I kind of get this cool sort of shaded view of it. And I'm ready to print. I can add in the scale. I should add in units like that. And you can add this in inches. Inches, check. Add in your name, the block, the date, and then over here, drawing number. So for the toy project, technically, I think this ends up being drawing 3 of 5. So this should be changed to a 3. And this should be changed to a 5. Again, this 5 depends on how many total planes you have to communicate your wooden toy design. And that may be 6, it may be 7, depending on how complex the toy is. But usually I think this is plane 3 in the order. So there you go. There's how you create a nice orthographic view dimensioned of the helicopter wooden toy. Good luck, and hopefully it was easy to follow along.